All right, if you've spent any time at all around a general aviation airport, you've heard the debate. It is a rivalry that feels as old as the hangar itself. A true clash of titans that powers most of the piston fleet. Lycoming versus Continental. And look, this goes way beyond just horsepower and specs. We're talking about culture, passion, and some really deeply held beliefs. These two names are so foundational to flying that their differences have literally fueled decades of hangar talk, friendly arguments, and some pretty fierce brand loyalty. Okay, so that's the big question, right? Let's actually try to answer it. We're going to break down everything: their design philosophies, the performance data, the reliability arguments, and we'll even look at what's happening on the experimental frontier to see if we can finally settle the score. At first glance, you might think they're basically twins. I mean, they're both typically four-cycle, air-cooled, horizontally opposed engines. But once you look under the cowling where it really counts, you see that their core design philosophies are just worlds apart. This chart right here is fantastic. It gives us a great overview of the key differences between these two giants. So let's unpack some of the most important points, starting with just their basic architecture. Let's start with the camshaft. Lycoming puts theirs up high, above the crankshaft. Continental, on the other hand, puts it down low. Now, that might sound like a tiny detail, but trust me, it impacts everything from how easy it is to work on to the engine's overall shape. And here's a difference you can really feel in the cockpit. Lycoming mounts its carburetor directly to the hot oil sump. The benefit? Well, all that heat helps prevent carburetor icing, which is a huge safety advantage. Continentals use a separate manifold, so you just don't get that same built-in protection. Okay, stepping away from the internal schematics for a second, there's a classic rule of thumb that pilots and mechanics have used for years to tell these engines apart just by looking at them on the ramp. It's a super simple visual cue. If you see just one exhaust pipe sticking out, chances are you're looking at a Lycoming. If you see two pipes, it's a really good bet that it's a Continental. It's not a perfect rule, but hey, it holds true for a lot of the common planes you'll see out there. Of course, and this is the crucial part, the pilot's operating handbook, the POH, is always the final word. Always. So use the exhaust trick for fun, but always trust the book for the facts. So how do these design choices affect performance? Well, because of how they're built, each manufacturer has kind of carved out its own corner of the market. They've earned these distinct reputations as either rugged, tough-as-nails workhorses or smooth, high-performance power plants. And you see this play out in the planes they power. Lycoming is the beating heart of the training fleet. Think of your Cessna 172s and Piper Archers. They're praised for being simple and just about bulletproof. Continentals, meanwhile, are often the engine of choice for the faster, more complex aircraft, like a Cirrus SR-22 or a Beechcraft Bonanza, where that smooth operation is really, really valued. Both companies offer just a massive range of power outputs for almost any airframe you can imagine. Lycoming starts with the humble 115 horsepower O235 and goes all the way up to the beastly 400 horsepower IO720. Continental covers a similar spectrum, but they're also pushing into some really cool new territory with advanced diesel engines, like the 300-horse V6 twin-turbo you'll find in the new Diamond DA50. Okay, now for the main event, reliability. This is where things get interesting. This is where the hard, objective data often collides with decades of hangar stories, really strong opinions, and real-world experience. If we look purely at the numbers from Aviation Consumer, Lycoming does have a slight edge. We're talking 0.91 in-flight failures for every 1,000 engines compared to Continental's 1.15. So yes, it's a statistical difference, but believe me, it is not the whole story. This quote just gets right to the heart of the pro-Lycoming feeling. There's this widely held belief, born from tough experience in flight schools and charter ops, that you can just work a Lycoming hard and it just keeps on going. They have absolutely earned that reputation for being incredibly durable. But the other side argues it's not about being better or worse. It's about understanding the engine you're flying. This perspective says that Continentals perform exceptionally well, but you have to operate them the way they want to be operated. They need to be warm. They need to be treated with a certain finesse that's maybe a little different from a Lycoming. So at the end of the day, both engines have these well-known trade-offs. Lycomings are famously robust, but if you don't fly them regularly, they can be prone to internal corrosion, especially on the camshaft. Continentals are prized for being smooth and often lighter, but they carry a reputation for having more valve issues and, higher cost for parts. All right, let's shift gears now and look at where this rivalry is headed today. The experimental or home-built aircraft market is this incredible hotbed of innovation, and both companies are competing fiercely with some really specialized, high-performance engine lines. For Lycoming, their custom shop is called Thunderbolt. For Continental, it's Titan. And let me be clear, these are not your standard certified engines. These are tailor-made power plants for builders who want to squeeze out every last drop of performance and customization. Lycoming's Thunderbolt program is all about this bespoke, white-glove experience. You actually work directly with an expert to customize everything. You can pick paint colors, ignition systems, fuel systems, and you can even get performance tuning, like porting and polishing, for extra horsepower. It's the whole shebang. Continental took a different and pretty smart approach with Titan. They bought a company called ECI that already had a fantastic product line. They focused on the most popular engine sizes for home builders, the 340 and 370, and they deliver a complete, factory-tested engine that's pretty much ready to bolt on and go fly. And this really highlights their different strategies. Thunderbolt is for the builder who wants to craft a totally unique engine, tweaking every single detail for max power and a personal touch. Titan is for the builder who values a proven, reliable, kind of off-the-shelf solution that's based on a really popular and trusted design. So, after all that, which engine is truly better? Well, the final verdict is there isn't one. The truth is the better engine is the one that's right for your specific mission. So, I'll turn the question back to you. What does your mission demand? Are you building a rugged backcountry machine that needs to be simple and utterly dependable? Or are you building a sleek, fast cross-country traveler where smoothness and efficiency are the most important things? The answer to the great engine debate isn't found on a spec sheet. It's found in the purpose of your next flight.